Dear students, in the last class I have explained important equations related to projectile motion, and these are called equations of projectile motion. So, the first equation is y is equal to ax minus bx square, where a is equal to tan theta and b is equal to g by 2 u square cos square theta. And the other equations of motions are time taken by the projectile to reach the maximum height, that is called time of ascent, which is a small t is equal to u sin theta by g, where what is u? So, u is velocity of projection and theta is the angle of projection and g is the acceleration due to gravity. Time taken by the projectile to describe the range is called time of flight, which is double the time of ascent, which is t, capital T is equal to u sin theta by g. Maximum horizontal distance reached by the projectile is called as the range, which is r is equal to u square sin height, the maximum height h is equal to u square sin square theta by 2g. And so, what is the maximum height? The height at which the velocity of the projectile is horizontal, and the range is given by r is equal to u square sin 2 theta by g. See the difference between the two equations. In h it is sin square theta, in the other case it is sin 2 theta, and that sin 2 theta is also given by 2 sin theta cos theta. So, these are the important formula based on which we will be solving numericals today. So, most of the numericals of this chapter will be completing it in today's session. So, let us see how important these equations are. So, the first question show that the trajectory of a projectile is a parabola. So, important derivation where you have to prove that y is equal to ax minus bx square. The question has appeared thrice in the examination. The next question, derive the expression for the maximum height reached. So, where you have to prove h is equal to u square sin square theta by 2g. So, question has appeared 4 times in the examination. And then even the time of flight. So, that is the second part of the question, capital T is equal to 2u sin theta by g, and the third one, the range of the projectile, which is r is equal to u square sin 2 theta by g. So, all these equations which we derived in the last class, they are definitely important from the exam point of view. So, let us see some more questions. So, maximum range of the projectile. So, r is equal to u square sin 2 theta by g. This is a formula for the range, and r depends on the maximum value of the sine function, and maximum value of the sine function is equal to 1. So, when sin 2 theta is 1, the range is maximum, r max, which is given by u square by g. So, this is the formula for maximum range. R is equal to, or r max is equal to u square by g. That is when sin 2 theta is equal to 1. Now, for what angle we will get sin value 1? That is when 2 theta is equal to 90 degree, sin 90 degree is 1. So, we know those are standard values, right. So, 2 theta is 90 degree, that implies that theta is equal to 45 degree. That means, whenever you project a projectile, it can be a shot put or a discus or a javelin, correct, you have to throw it at an angle of how much? 45 degree. So, those who are interested in participating in these kind of events, so this is the one important point which you have to remember. So, therefore, your hand movement, it should be at an angle of how much? Exactly 45 degree with the horizontal. Only when you project it at an angle of 45 degree, it will reach the maximum horizontal distance, not the maximum height, because the winner is decided by the horizontal range and not the maximum height. So, for what angle of projection the range is maximum? When theta is 45 degree. So, therefore, you have to practice in such a way that your hand movement is at an angle of exactly almost equal to that of 45 degree. Okay, that is r max. So, this is a maximum range. So, you get to see in this particular animation where, see, for different angle, the first one is for 10 degree. For 10 degree it falls here. The next is for 30 degree. For 30 degree it falls here. And you can see for 45 degree, the one which is moving right now, see this is the one which reaches the maximum horizontal distance. Clear? And then for 60 degree, again it falls here. Then for 80 degree, it will fall here. Clear? So therefore it is not the larger angle, it is important. It is the what angle? At 45 degree, if you project it, it will reach the maximum horizontal. So it will reach here. So that is what is required to decide the winner in all these events like javelin, then there is a shot put, there is a discus, so there is a hammer throw. So in all these, the range is important, and at what angle you can achieve the maximum range? At an angle of 45 degrees. So this is a good animation to understand that the range is a maximum. Okay, so let's go through some of the question. First one, write the expression for the range of the projectile. Okay, so this is the expression for the range of the projectile. R is equal to u square sine 2 theta by h. For what angle of projection it is maximum? So it is a maximum for an angle of 45 degree. Write the expression for the maximum range. The maximum range R max is given by u square by g. So this is a formula. These are all questions from the previous exam. So hope you have understood the answer to all these questions. Expression for maximum range and height of the projectile. Okay. So expression for height h is equal to u square sine square theta by 2g. So u square, when theta is 45 degree, sine square 45 degree divided by 2g. U square by 2g. See the value of sine 45 from the standard angle. Sine 45 is 1 by root 2. Square of it will give you 1 by 2. So therefore, you will get u square by 4g. So, but we know that h is equal to here u square by g is nothing but R max. So, it is R max by 4 or R max is equal to 4h. So, this is a relation between the maximum range and the height of the projectile. Okay. So, range of the projectile is always 4 times the maximum height. Okay. Maximum range. So, when R max is here, when theta is 45 degree, then it will be always equal to 4 times the height reached by the projectile. That is what the statement is all about. Expression for maximum range. Okay, this is important, not just the formula for range. This is the formula for range. This is the formula for maximum range. Okay, at what angle we achieve maximum range? At an angle of 45 degree. So expression for maximum range and the height of the projectile is given by R max is equal to 4h. Hope you are clear with that. So let's try one numerical, and you can see this question has appeared 4 times in the examination, and they may change the data, they may change the value, but the problem remains the same. Instead of 30 degree, they may give 45 degree. Instead of initial velocity 20 meter per second, they may give some other value. So they may change the values, okay, but the main numericals remains the same. Okay, let's go through this statement. A cricket ball is thrown at a speed of 56 meter per second. So I'm going to write here. So initial velocity of projection is 56 meter per second in a direction 30 degree above the horizontal. So angle of projection is given, theta is 30 degree. So that's given, 30 degree above the horizontal. Option A, the maximum height. So we have to find h, maximum height, which is u square sine square theta by g. So this is what the formula to be used. I will do the calculation. Next, option B, the time taken by the ball to return to the same level. That means if it is thrown here, it should reach back here. That is time of flight. So which is a t is equal to 2u sine theta by g. And the value of g is given at the end of it. So which is 9.8 meter per second square. Option C. Option C. The distance from the thrower to the point where the ball returns to the same level. So distance from the thrower to the point where the ball returns to the same level. That means if it is thrown from here, it falls back. So therefore, from the thrower to the level where it falls back, that means I have to find the range, which is r. R is equal to u square sine 2 theta by g. So this is what we need to calculate. So that's it. So 3 options, very simple. So I'm going to do the substitution now. So u is a 56 square into sine square 30 by 9.8. So first let's find 56 square using the calculator, which is 3136 into sine 30 degree. Okay, sine 30 degree is half, 0.5, but there is a square, okay, by 9.8. So this is 3136, 0.5 square is 0.25 by 9.8. So 3136 into 0.25 divided by 9.8. So that will give you ET. We are finding the height, so that's why it is in meter. Okay. So hope you have understood that. Next, 2 into the value u is 56 sine 30 here, sine 30 divided by 9.8. So 2 into 56 into sine 30 is half, 0.5 by 9.8. So 0.5 into 2 is 1, so we'll get 56 by 9.8. So 56 divided by 9.8 will give you 5.714. We are finding the time, so that will be in second. Next, r is equal to u square sine 2 theta by g. So 56 square into sine theta is 30 into 2 is a sine 60 degree divided by g, which is 9.8. Now 56 square is already calculated here, which is a 3136 into sine 60 is nothing but a root 3 by 2. Now that is a standard angle, right? Root 3 by 2, sine 60 only root 3 by 2 divided by 9.8. So this is 3136 into root 3, which is a 1.732 divided by 2 will give you 0.8660 by 9.8. So 3136 into 0.8660 divided by 9.8, which is a 277.12. It's a horizontal range that we are calculating, so it's in meter. So therefore, you need to remember all these as standard angle again. Sine 0, 0, sine 30 is half, sine 45 1 by root 2, sine 60 degree root 3 by 2, sine 90 is 1, even cos values also, like cos 0 is 1, cos 30 is root 3 by 2, cos 45 1 by root 2, cos 60 is half, and cos 90 is 0. Similarly, tan value, tan 0 is 0, tan 30 is 1 by root 2, tan 45 1, tan 60 is root 3, and tan 90 is infinity. Okay, so the table given, so do revise them. It's very important in substituting the values here. Okay, so hope you have understood that particular important problem. So that has appeared many times in the examination. It's just a substitution problem. So first you should remember all the formulas, the maximum height, the time of flight, the range, everything. Only then you'll be able to attempt these problems. So it's important, first you have to learn the theory part. Without learning the theory, it's not possible to solve the numericals. Okay, all right. So let's go for next question. The next question is: a cricket ball is thrown at a speed of 56 meter per second in a direction 30 degree above the horizontal. I think this is what we solved, right? Yeah. So the next one, a football player kicks a ball at a distance of 10 meter from a vertical pole. Okay, so let me draw the diagram for this. So here there is a vertical pole is given like this, right? A football player kicks a ball at a distance 10 meter. So 10 meter. This is 10 meter. So the ball is here. This is the vertical pole, okay, at an angle of 45 degrees. So angle of projection is given, theta is 45 degree. The ball just clears the tip of the pole and falls at a distance of 10 meter from the other side. So this ball which is kicked, it will clear the pole and then it will fall here like this. Again at a distance of 10 meter on the other side. This is 10 meter. Pole and falls at a distance of 10 meter on the other side. So determine the height of the vertical pole. So we have to find h. What is the value of this h? So theta is given, the value of g is also given, which is 9.8 meter per second square. Okay. Now see, when theta is 45 degree, when theta is 45 degree, R max is a given, which is u square by g, correct? And this is horizontal distance. See, this is R max because theta is 45 degree. So R max is given, that is 10 plus 10 here, that is 20 meter. And when theta is 45 degree, R max is u square by g, and then h is a u square by 4g, and based on this we get R max by 4, correct? When theta is 45 degree, we already know that the maximum range is u square by g, height is given by u square by 4g, or I have already given that R max is nothing but 4h. So what is the value of R max? R max is 20 by 4, that is 5 meters. So therefore this is the value of the height of the vertical pole. Okay. So hope you have understood the theory. So how we could assume that this is the maximum range, because based on the angle. So we know that the range is maximum when the angle of projection is how much? 45 degree. Okay. So very easy numerical based on the last point which I had explained it. Clear? Okay, so let's try the next numerical now. Statement: the ceiling of a long hall is 25 meter high. So this is the ceiling, this is the floor. So this height is given 25 meter. What is the maximum horizontal distance that a ball thrown with the speed of 40 meter per second? So a ball is thrown with the speed of 40 meter per second. Can go without hitting the ceiling. Suppose if there is a ball here, when hit, it will move like this, it will just clear the ceiling and then it will fall here. And they've asked what is the maximum horizontal distance that it will cover. That means I have to find the value of R. And the value of G given 9.8 meter per second square. H is given 25. Here we cannot use R max is equal to 4h because theta is not given. Here theta is not 45 degree. It is not mentioned in the question. So that is why we have to find that angle of projection. So when I know the value of h, when we know the value of u and g, I can find a theta. How? So use the formula h is equal to u square sine square theta by 2g. Or sine square theta is equal to 2gh by u square, that is 2 into 9.8 into h is 25 divided by the value of u, which is 40 square 1600. So here we have 25 into 2, 50, 50 into 9.8 is 490 divided by 1600. So let's calculate this. 490 divided by 1600, which is 0.30625. But that is a sine square theta. So what is sine theta then? So sine theta is equal to square root of 0.30625. So which is 0.5533. 0.5533. See, when we know sine theta is 0.5533, I can find the value of theta using sine inverse of 0.5533. For this, to find this angle, we need the natural sine table. So that I will use it now. So here there is a table to find the angle, 0.5533. Let's check where exactly that nearest value, 0.5533. So here we have the value 0.5534 is there. So which is 33 degree, 36 minutes. So the value of theta is 33 degree, 36 minutes is the angle. Okay, that's based on this value 0.5533. Check where the value 0.5. See, this is 0.5446. 5461 and so on. Okay, so here we get 0.5534, which is the nearest to this. So therefore the angle is 33 degree here, and the minutes above, see here it is 36 minutes. So 33 degree, 36 minutes is the value of theta. Okay, now since we have found theta, now I need to find the value of range, that is r is equal to u square sine 2 theta by g. So first I'll find 2 theta here. So what is the 2 theta? Twice this value, 33 degree, 36 minutes. This is 33 into 2 is 66 degree, 72 minutes, 72 minutes. But you know, when the angle, when this minutes exceeds 60 degree, we can convert, because 60 minutes, it becomes a 1 degree, because we know that 1 degree is equal to 60 minutes. So therefore, this is 72 minutes I can split into 60 plus 12, right? 72 minutes is nothing but 60 minutes plus 12 minutes. 60 minutes is nothing but 1 degree plus 12 minutes. So therefore, it's a 1 degree 12 minutes. So that's why we write this 66 degree 72 minutes is equal to 66 plus 1, 67 degree 12 minutes. Okay, so 67 degree 12 minutes. So that is how we can write it here. So now let's substitute u. What is u? 40, square of it 1600 into sine 67 degree 12 minutes, 67 degree 12 minutes divided by 9.8, 1600. Now to find the sine 67, again we need the natural sine table. So that is what I am going to use now. The next, which is 67 degree 12 minutes. So 67 degrees here, 12 minutes is here. So therefore it's a 0.9219. 0.9219 divided by 9.8. So 1600 into, let's simplify this, there is no need to write the next step. So therefore here we have 1600 into 0.9219 divided by 9.8, which is 150.5 meters. So that's the value of this range. So therefore here you can make use of this table while finding these angles. Even in the exam you will be provided this particular table, so you can use that in finding the angles other than this standard angles. So because we know the values of the standard angles, but when it comes to other angles other than those the standard then we can definitely make use of this table from the Clark's table, that book which is provided. Okay. So, hope you have understood how we can find the angle, and then we can substitute in finding the other physical quantities or other variables. Okay. Right. So, let us go through one more question. So, we have already provided that natural sine table to you all, that book is provided. So, refer that and then see how I have found the value using the natural sine table. Okay. Yeah. Next question. A cricketer can throw a ball to a maximum horizontal distance of 100 meter. So, maximum horizontal means R max, which is given 100 meter, and R max is u square by g, when theta is 45 degree. How much high above the ground can the cricketer throw the same ball? How much high means, it's like vertical. Okay. So, when a person throws vertical, the angle of projection has to be 90 degree, correct? So, if you project it like this, then this is theta. Maximum, how high means maximum, right? Then theta becomes 90 degree. So, when theta is 90 degree, H is a maximum. R is maximum when theta is 45 degree. Okay. When theta is 90 degree, H is maximum, and that H is given by u square sine square theta by 2g. So, H max is equal to u square sine 90, here sine 90 is 1, divided by 2g, that is u square by 2g. But u square by g is nothing but R max, correct? So, therefore, it is R max by 2. So, R max is already given, right? It is 100, it's 100 by 2, that is 50 meter. So, this is a different formula other than what we have given, that R max is equal to 4h when theta is 90 degree, when theta is 45 degree. But they have given here how much high above the ground, like this, high above the ground. That means how much vertically one can throw, and that is possible only when theta is 45 degree. Okay. So, this is the explanation to this particular question. They have given maximum range when theta is 45 degree, and how much high above the ground means we have to consider theta 90 degree and not equal to 45 degree, and based on that we get H max is equal to R max by 2, 100 by 2, which is equal to 50 meter. So, hope you have understood this particular question. So, now let us go through one more question, the last numerical based on this particular topic statement. So, a hiker stands on the edge of a cliff. Hiker means it is a mountaineer, stands on the edge of the cliff. So, let us consider this is the edge of the cliff here, edge of the cliff 490 meter above the ground. So, therefore, height is given h 490 meter above the ground, and throws a stone horizontally. So, he throws a stone horizontally like this, horizontally with an initial speed of 15 meter per second. So, horizontal means its initial horizontal ux is 15 meter per second. Where and when will the stone strike the ground, and with what velocity it will strike? Yeah. So, it will fall and then it will strike the ground like this. Okay. So, we need to find when and where means at what distance, and after what time, and then we have to find the velocity. The value of g is given, which is 9.8 meter per second square. See here, whenever it moves like this, it moves in a projectile motion. So therefore, there will be always a horizontal motion as well as the vertical motion. So first I am going to consider the vertical motion. Okay, then we will consider the horizontal motion. Now at the highest point here, vertical motion, I am going to write at A. At A, the velocity is exactly horizontal, therefore there is no initial velocity in the downward direction, there is no vertical velocity because it is moving horizontally, correct? So therefore, initial velocity along the vertical, which is along y axis, is always 0. What is the distance covered along the y axis, which is h, height? Okay. So here distance travel along the y axis is nothing but h, which is a 490 meter. What is the acceleration along this direction? It is nothing but acceleration due to gravity, which is ay, and it's moving downward, so it's positive. So g, which is 9.8 meter per second square. So based on this, I can find the time taken, t, time taken to reach the ground or to reach this particular position. So using Sy is equal to ut plus half at square. So everything along the y axis. What is Sy? It is a 490. This is 0 plus half. Ay is nothing but 9.8 into t square. So 490, this is 4.9 t square. So t square is equal for 490 by 4.9 is 100, therefore the value of t is a 10 seconds. So time taken by the stone to reach the ground is 10 seconds. Now let us consider the horizontal motion along the horizontal. So what is the distance covered? That is to be calculated, where it falls. So distance along the horizontal is r, that is to be calculated. And along the horizontal there is no acceleration, so acceleration is always 0. Because we know that in projectile motion along the horizontal, the nature of motion of the body is uniform velocity, so x is 0. What is the time taken? It is already calculated, 10 seconds. What is the velocity along the horizontal? That is a given, ux, 15 meter per second. So therefore now we can calculate Sx is equal to ut plus half at square, but everything along the x axis. What is Sx? That is to be calculated where it falls. And what is the ux? It is given 15 into t is given 10, and this is 0. So therefore the range is 150 meter. So therefore in the question they asked when and where the stone will fall, correct? It will fall at a distance of 150 meter after a time of 10 seconds, correct? And now you are asked to find what is the velocity with which it falls. So first let us calculate the velocity along the y axis, okay? Velocity along the y axis, that is what we are going to calculate. So Vy is equal to u plus at, that is uy ay into t. What is uy? It is a 0. Here it is, uy is 0. Ay is nothing but 9.8 into time taken 10. So that will be 98 meter per second. That is Vy it is, okay. What is the value of the velocity along the horizontal? That will remain the same, 15 meter per second only. Vx is 15 meter per second only. Why it remains 15 meter per second? Because along the horizontal the nature of motion is uniform velocity. So therefore now finally what is the resultant? The resultant is given by square root of Vx square plus Vy square, whenever two vectors are perpendicular, the resultant is given by root of p square plus q square. So, that is the basis on which I am writing that particular equation. That is equal to root of, what is the Vx? Vx is 15 square of it, which is 225, plus we have Vy, which is a 98 square. 98 square. So, let us find the value of this. So, first we have 98 square, then we have plus 225, then we have to take the square root of it. That will come 99.14 meter per second. 99.14 meter per second. So, this is the velocity with which the stone reaches the ground. Okay. So, hope you will have understood all the numericals that I have solved based on this particular topic. So, we have again one more topic left, which is about circular motion. So, that is in my next class. So, start reading students, because there will be a test soon. So, before that there will be an interactive session. So, after that I am going to conduct the test. Okay. Thank you.